Hi, I'm Phil Layler, Consulting Director at STL Partners. This is a short video that's going to respond to some questions that were asked of us following our study of the impact on 5G on carbon emissions from mobile networks. The question raised is, this analysis that STL's undertaken focuses purely on the electrical energy needed to run the network. What about emissions arising from all of that installed kit, the embedded carbon, and the emissions arising from actually doing the installation? And how about all of those mobile phones that people will be buying? Let's take a step back and have a look at how companies typically report their carbon emissions. What most companies do is they report carbon emissions in three ways. They talk about scope 1, and that's the direct emissions from their activities, from combusting fuel, from driving trucks, and that's the carbon emissions that they produce from their core activities. What we focused on is scope 2, and that is the carbon emissions that are generated by the use of electricity that's been purchased, bought in, or generated internally for the purposes of running the service. And the other area that can be reported against is what's called scope 3, and that's the upstream goods and services that are purchased and the embedded carbon within them, but it's also the end of life, and therefore the carbon emissions arising from having to clean up and recycle and deliver the products after they've left your site. And all of these are generating greenhouse gases, and they are being reported against under scope 1, 2, and 3. Now, what we did in our analysis was to focus on the delta. In other words, we took a base case and we wanted to look at what is the relative impact, different scenarios of 5G rollout. So what's really important for us isn't the absolute emissions from the mobile networks, it's what's different as you move to 5G or you accelerate the 5G rollout. Let's start with scope 1 and let's focus on the difference between scenarios that we set out for. That's the fast rollout versus slow rollout 5G scenarios. When it comes to scope 1, we're talking about the business of building out the network. That's the carbon embedded in the equipment that gets installed, but it's also the carbon associated with running and managing the network, the truck rolls, if you like, and that activity. And here you can argue, well, it may be that initially there's some carbon emissions associated with that initial deployment of 5G, but over the course of its life, and the better analytics, the better maintenance, the greater automation that comes from 5G may actually reduce the overall scope 1. Furthermore, if you think about it, the data demand continues to drive the need to upgrade the 4G networks, then is that really going to be a lower footprint? Arguably, it could even be a higher carbon footprint arising from those continuous upgrades that have been less efficient than the 5G deployment. Scope 3 is potentially a very significant source of carbon emissions from operators, but it's very complex. It's very complex because it's got lots of suppliers, lots of moving parts, and then there's lots of downstream consequences of operator services. And what makes it even more complex is trying to balance out all of those different effects. First of all, very few operators report scope 3. Secondly, even those that do adopt different methodologies. And thirdly, a lot of operators actually look to understand how their services reduce carbon emissions from their customers' activities. And here again, this is an area we're currently undertaking a new study on, but we believe that 5G has a bigger impact when it comes to increasing global energy efficiency, global electricity production, and essentially it has a positive impact on downstream businesses. So it's a very difficult one to call, and again, arguably, you could say there's a net benefit from 5G. So in summary, we focus on scope 2 because scope 1 is relatively modest and it's hard to really tell the difference between a 5G or an increasing rollout of 4G. Scope 3 is incredibly complex and there isn't a standard methodology. Here again, it's less about not being able to tell the difference between 4G and 5G, it's really being able to figure out, well, what's the net impact? And there's a strong case to argue that there is actually a positive net impact from carbon emissions arising from scope 3. In fact, we're undertaking another study that's looking into more detail about how 5G technologies can help to accelerate deployment and adoption of key low-carbon technologies such as renewable energy sources. Well, that was a 2-minute overview in response to that question. There are some other questions that you can go and check out on the site. In the meanwhile, if there's anything else you want to know, particularly about our current research looking into the impact that 5G can do to help the renewables industry, please don't hesitate to contact us. Thanks for listening.